Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. The hard part is in deciding which test to use. Well, press pause and have a go. Okay, so to do this, if you look at this, 1 over n is the exact derivative of this bubble here. So you should have a hunch. Well, this here is easy to integrate. So you should have a hunch that you should use the integral test. But before we use the integral test, let's just have a quick glance at the nth term test. The nth term test is us looking at this, compute this thing here. As n heads towards infinity, you're going to have 1 over, well, as n heads towards infinity, the denominator is going to head towards infinity. So you're going to have 1 over a very, very big number. So it's going to head towards 0. So you can't really determine anything. If it heads towards, let's say, any number above 0, then you can be 100% sure it's going to diverge. But in our case, it's going to head towards 0. So we can't determine anything. So we've got to use something else. Well, when you look at this, you can see that this is the exact derivative of this. So it should be easy to integrate. So you should use the integral test. So to use the integral test, we would map a continuous function on top of this thing here. So now let's look at this and make sure this thing here is continuous. Make sure it's always positive in the realm from 2 to infinity, which it will be because this will be positive. Natural log looks like this. This is 1 here. Anything above 2 onwards, it will be positive. So this will be positive. This will be positive. The whole thing would be positive. Therefore, this thing here would be positive. So it's always continuous. It's always positive. Yes, it is decreasing. You can differentiate, find f prime if you want to, but as x moves on, it's always decreasing. So now, if you're not convinced of this, then differentiate this, and then you can see that. Well, differentiate it. We've done this before, so you should. Well, this has been satisfied. Now we can use the integral test. So integral test would mean we would integrate this from 2 to infinity. If this whole thing here converge, then the series that we're trying to investigate will also converge. Okay, so let's try and find the integral of this from 2 to infinity. So integrate this. Well, you could use integration by substitution, but try to do it. Well, it's up to you how you do it. But this method's easier once you've mastered it. If you look at this, this is the exact derivative of this. So when you look at this, in your mind, visualize this, because if you look at this here, this is 1 over natural log x squared, which is the same as natural log of x to the power of -2. So because you know that this is going to be the exact derivative of this, let's just forget about this for the time being. So when you look at this, try to picture this in your mind. So you are looking for something that when you differentiate it, it will give you something along this line. Well, you know it's going to be 1 notch above this. So in your mind you would visualize this, but then you make this to be your initial guess, because you alright, sorry, let's start again. When you look at this, in your mind picture this. You are looking for something that when you differentiate it, it will give you something along the line of this. So you know it's going to be 1 notch higher than this. So make your initial guess to be natural log of x to the power of 1 notch higher, which would be -1. So make this to be your initial guess. So making this to be your initial guess, if you differentiate it, it will be -1, and then natural log of x. And then this gets minus by 1, so it'd be -2. But then you've got to times the derivative of the bubble itself, which would be 1 over x, which is this bit here. So now this is this bit here. This is this bit here. So now you just need to negate this this -1. So you would go back to your initial guess. This is your initial guess, and then negate this 1. So stick a -1 in there. So now, if you stick a -1 into here, and then if you differentiate it, it will then give you this whole thing here. So when you integrate this, it will be this. Or you can use substitution, integration by substitution. It's up to you. Okay, well, integrate this. So hang on. So integrate this, it will then give you this. So now you're doing it from 2 to infinity to infinity. So you can put this into here. So remember, infinity is not really a number. You're just it's just a lazy way of us putting a very it's just a lazy way of us communicating. We are putting a very big number into this bit here. So this here, a natural log of infinity. Infinity is not really a number. So it's just a lazy way of us communicating that we are going to put a very big number into here. Well, anyway, 1 divided by a very big number. So 1 divided by well, natural log of infinity is going to be infinity. So this thing here is going to be this bubble here is going to get bigger and bigger. 1 divided by something that keeps on getting bigger and bigger. Eventually, it's going to be 0. So hang on. So once you're here, rewrite this. So basically switch these two around. So that will then give you this. So move this over here. That will then give you this. This will eventually head towards 0. So therefore, the integral comes to a finite number. So therefore, the integral will converge. So therefore, this series will also converge. So our series here will converge. Okay.